Okay. Hello, everyone. Welcome to the second Advanced Java class. Um, I'm your instructor, Mr. Nawasu. I suppose we can just get started. All right. Okay. All right. So last class, we focused on exception handling. So we could do a quick little review. Um, can you guys, well, first off, can everyone hear me okay? All right. All right. Thank you. Okay. So from exception handling, what keywords do you guys remember and what do they do? I'll give you guys a hint. One keyword that we discussed last week was the try keyword. Yep. Go ahead, Audrey.
Um, so try is like you can like try to like do something, and then accept is like if you have an exception, and finally it's like you always do that.
Yep, that's exactly right. Yes, good job, Audrey. So those are pretty much the three main keywords in exception handling. We have the try block, which is what the code block that you want to try. And then you have the accept block, which is the code that'll happen if something goes wrong in the try block. And then you have finally, the finally block that will get executed regardless of what happens in the try or accept blocks. So yeah, yep, good job. So I suppose we can move on. Um, so the focus of this lecture will be on time, on how Python handles time. Um, so a Python program can handle date and time in several ways. Converting between date formats is a common chore for computers. Python's time and calendar modules help track dates and times. So the time intervals are floating point numbers in units of seconds. Particular instants in time are expressed in seconds since 12 a.m. January 1st, 1970, also called an epoch. So that's how Python handles date and time. And the way that Python handles date and time is actually a lot easier compared to how Java and C++ and other languages handles date and time. So we'll be seeing that in the lecture today. So let's do one exercise to see how time works in Python. You can use the time method to get the current tick number that your system clock provides. So let's try this code out. So the first thing that we need to do um, is import a module called time, which I will do in a second. Okay, so we import time. Um, and then we use this code block to get the current tick number from uh, from our system. So we set ticks to be equal to time.time, and what we call the time method. And then we print out the number of ticks. So if we run this code, we get the number of ticks since 12 a.m. Jan 1st, 1970 is this floating point number right here. Okay. Um, let's see what else. So yeah, that's one example of time. Um, with the capability of knowing the tick value, let's use it to find out how long it takes to do a loop. Let's try out this code block here. Okay. So in this code block, we're setting variables x and y to 2 and 1. And then we set start time to be equal to time dot time, which if you guys remember, gives the number of ticks to start that loop. And then y will be equal to y plus, this looks like 1 million. And then we'll print out both x and y. And then once x is greater than y, we're going to break. And then we get the end time down here. So from this explanation, what this code is essentially doing is that we're timing how long it'll take for us to do this code block right here. Because we have our start time, we're getting our start time, and then we're also getting our end time. And then by subtracting end time from start time, we get the number of seconds from end time to start time. Does that make sense to everybody? All right. So let's run this code. Okay. So I ran this. It ran for a few iterations, it looks like. So it took 0.00199 seconds for x to become greater than y. And we were able to get this seconds number by subtracting end time from start time. Okay. So this is an example of using Python's time.time module, or the time method in the time module, to calculate how many seconds it takes to do a block of code. We can ask the system to sleep while we can ask the system to sleep a while when it executes our Python code with time.sleep, and then you can put in the number of seconds that you want. The system will sleep for the seconds you specify as the argument value. So let's add time.sleep 0.01 to the loop and see the result. Sometimes you want to use sleep to force your application to wait some time. Yeah, so let's add time.sleep to our code. Let's add it right after the print statement. So we're going to use time.sleep to have our program sleep for 0.01 seconds after we print out X and Y. So when we run this, we'll notice that the code runs a bit slower now. Yep, so now the code took 1.21 seconds to run. And it took 1.20 run rather than the 0.0019 that we saw before, because we haven't programmed sleep forced the program to like hang on for a bit. Oh, let's see, my I Can you guys hear me okay?
Yeah.
All right, Henry, do you have a question?
Can we make the code so that y is never greater than x and goes on forever?
We could, so let's see, we could make y equal to y, actually, I'll just copy this so that we don't lose our y. So we can make y equal to y times 1.3. So if we do this, the code will run forever. Um, so yeah, I'll run this so that you guys can see what it looks like. All right, why is it finished? That's weird. Oh, because because y is one. All right, so I'll change y to 2. Yeah, so this is gonna run forever because y will always be greater than x. So I'm gonna stop it now. Let's see if I can stop it. Oh, it stopped by itself. Oh no, it's still going. All right, I just interrupted it. So yeah, it's possible to have it infinite to have an infinite loop. Um, and you guys just saw an example of that. So yeah. Um, and we can see that both x and y are really big numbers here. So yes. All right, moving on. Let's see, these two websites have detailed information about time. Uh, so we could spend some some minutes on them. So um, this is the library I mean these are the functions for the time package in Python. So as I mentioned early in the lecture, the epoch is the point where the time starts. So the epoch starts in January 1st, 1970. Let's look for some functions. Uh, okay. So get local time is a pretty common one. What this does is that it converts to local time, essentially. So judging by the name, let's see some other common time. Oh, so we see time dot sleep here. So time dot sleep is what we just practiced. It suspends execution for a number of seconds. What else do we have here? We have strip time. So what the strip time method does is that it parses a string representing a time according to a format. And this is what it looks like in practice. So you would do time.strip time. And then you would give it a date, and then it would strip it for you. We see time.time, which just returns the time in seconds since the epoch as a floating number. We saw that one in practice. So yeah, those are some of the common methods in the time library. Let's see some more. See, a Python program can handle datetime in several ways. Converting between datetime formats is a common chore. Let's see. Uh, this page explains what a tick is. Um, this page explains how to get the current time. So we see local time again, time.local time. We can get formatted time. So yeah, this page is actually very helpful for understanding the concepts behind the date time library in Python. So I'll make sure to post the link to this I'll post it in the chat now actually, and I'll also post it on the Google Classroom. All right. So many of Python's time functions handles time as a tuple of 9 numbers. Time.struct as shown in this table. Well, actually, before I move on, does anyone have any questions about what we've seen so far? All right. So let's see. The time Python handles time functions as a tuple of 9 numbers. So with time.struct time, we have indices 0 to 8, and then we have fields like the year, the month, the hour, the second, day of the week, day of the year. So it can get pretty detailed. Let's see an example of this. Uh, okay. So we have some more examples of the time functions that we saw in the previous page. Let's run this. Uh, so using time.gmt time, we can get the current time as that struct that we saw earlier. So we see that we have the year, index 0. We have the month, the day, the hour, the minute, the second, the weekday, since it's Monday, it's 0. The 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 year, like the day of the year. So we're on we're on June 19th, which is day 170. And we also have whether it's daylight savings time or not. Um, so yeah, so this is how struct time is structured. Yes, Audrey?
Is this in Eastern time?
Eastern time? Um, I'm sure that there's a way that Python handles time zones. We may see an example of that um, in the code later on. So yeah, so we will definitely get back to that question. We also have using a value of seconds. Well, actually, let me. So we're setting x to be equal to time.gm time, and then we're giving it a second as the value. So by running this, we're going to get a structure like this, seconds that we inputted. So we're going to get a really. So now we're getting the year 1970. We're getting the month October. The time of day is 12, and yada yada. So what this struct here is telling us is that this is the struct time for the number of seconds that have passed since January 1st, 1970. And this is the number of seconds that have passed, 2, 4, 5, 6, 7, 8, 9, 5. Since Jan 1st, 1970. And then we get the struct time down here. We can just as easily like put in a different number. We can put in the C1, add in a bunch of zeros to see to see what date that we get. Oh, what? Oh, maybe put in too big of a number. Let's see. Oh, oh, that's weird. But anyway, this function is supposed to take a number of seconds and then output the struct time for that, like for the number of seconds that have passed since the starting epoch. So this will give you a different values for each second that you put in. All right. So getting current time and formatted time. So we see local time again. So we're setting local time to be equal to time dot local time, and then we print the local time. So with time dot local time, we get the time struct for the local time. So we get the current date, the current year, the current time, and everything. And similarly, we can run time.ASCII time to get a pretty printed time format, as we will see in a second. So instead of doing time.local time like before, we're doing time.ask time or ASC time, and we're putting in time.local time as the argument. So if we run this, we'll get a prettier version of time struct. Okay. Any questions about GM time or local time or ask or ASCII time? All right. Moving on. So we can also access the value in the tuple. Yeah, a lot of the functions in the time package and module are pretty straightforward. It's just knowing what to use and when to use them. So we're setting local time to equal to time to be equal to time dot local time again. And then we're printing the current year by accessing the first item in local time. So by running this, we get year is 2023 because the first index of the time struct is the year, or the 0th index, I suppose. All right, so we have an exercise. Write code to print out the month and the weekday of the current time. So we can work on this exercise together. Perhaps it'll be easier if I uncommented this. Okay. So our objective is to write code to print out the month and the weekday of the current time, month and weekday. So given this time struct here, what indices should I access in order to get the current month and the current weekday? And anyone have any ideas? So I should be accessing local time and then like some index. So we see that the month is here. What index is the month right here? We know that that year is 0. What index is TM underscore mon? All right, Yes, Henry?
Is it TM month?
Yeah. Yeah. And one index is TM month. It should be a number. Is it 0, 1, 2?
I think 6.
It's actually going to be 1. So remember that local time is this time that's struct right here, which is a tuple, and we want to access the time dot mon, which is the second element of this tuple. And to access the second element, we have to do local time 1. And similarly, to access the weekday, which is right here, it's going to be 0, 1, 2, 3, 4, 5, 6. So we're going to access local time bracket 6. So by running this code, we get the month is 6 and the weekday is 0 because Monday is 0. Any questions about that exercise? All right. Okay, moving on. So we could also use the time.strip time method or function to strip a date time string. So right now we're inputting 30 November 00, and we have to specify that with this syntax that with %d, the first one is going to be the day, so we're going to do %d. The second one is the month, so we're going to do %b, and the third one is the year, so we're going to do %y. We have to specify these for strip time so that it knows like what it's dealing with, like what order the date stuff is. So by running this, what the, oh, I forgot to comment this out. So by running this, we get the same time dot struct. It's pretty much, but everything else is left. Oh, actually, it was, so Python was able to figure out that November 30th to 2000 was a, well, Wednesday, Tuesday, was a Wednesday, no, what was a Thursday? Yes, it was able to figure out that it was a Thursday and that it was not daylight saving standards time, and that the time and that the year, the um so we can use strip time. So the main thing to get time, and we could give it a date, and Python will be able to figure out some other things about that date, and it will return a struct time tuple. See, the struct time tuple is pretty powerful, and you'll see it a lot when you're working with time in Python. Okay. Okay. So here we have what more of these percents mean. As we saw earlier on, we saw that that %b is the locale's abbreviated month name. And then uppercase B is the locale's full month name. A is the weekday name, so on and so forth. There's some more here. We could have month as a decimal number, second as a decimal number. What they pretty much mean is you're telling Python what format the date time that you're putting in, essentially. So going back to our code, we told Python that that 30 was a percent D, that B was a percent B, and that 00 was a percent Y. And then Python went to this table and saw, okay, what does percent Y mean? Well, there's no percent Y here. What does percent B mean? Percent B means the abbreviated month name. And then with that, I was able to figure out that NOV means November. Okay, so here's Y. Yeah, so we used Y earlier. Yes, these are all the directives. All the percent. All right. So let's see. Sorry, it seems like my connection dropped for a second. Can everyone see and hear me okay? Okay. Yeah, sorry about that, guys. I don't know what happened. Um, all right, let's run this code block. And then we could talk about what it's doing. Okay, so for this code block, we're setting seconds equal to we're setting seconds to be this big number. And then we're using time.local time to get the struct time. So it's that couple of numbers that I've been talking about. And then with MK time, this is a new function. So what MK time does is that given a struct time, it gives you the number of seconds. So let's run this. So we have T1 is the struct time right here. It gives what we expect, a year, a month, a day, hour, minute, everything else. And then with time.mk time, we give it a struct time, and then it gives us back the seconds. So we got the number of seconds back, which matches the number of seconds that we put in for local time. Okay. So one question that we can ask is, can we try to use a negative value for local time? So what do you guys think will happen if we put in a negative number for local time? I'm curious. Yes, Henry?
I think it's going to be an error.
All right, let's see. Yep, it gave an error because putting in negative seconds doesn't make sense. So what can we do if time is before epoch? Let's see. So what happens if you want to work with a date time that's before January 1st, 1970, which is our first epoch? We could use strip time to do that. So by running this code, we are running code for November 10th, year one. So yeah, November, I wanted to know what life was like in November 10th, year one. Um, so with that, we can work with dates that's before the first epoch. We get this, we use strip time on the year, on the date that we put in, and it'll give us a struct time that's before the first epoch. Okay. So that's how we can kind of get around um, uh, getting before the first epoch in Python. So no, I guess there's one thing like that I should add. No year can be less than one, so no BC years. Yep, no BC years. So sorry if you're an ancient Greek, I suppose, but yep, since no year can be less than one, there are no BC years. All right. Okay, so let's do a little quiz. What will be the output of the following Python code? Let me blow this up a little bit more. So what will be the output of the following Python code? So we set t to be equal to 2010, 9, 20. So pretty much the same as the struct time tuples. And then we're going to do time.asc time. And then we're getting our answer here. So this will require having some knowledge of the orderings of the struct time that we've been working with for a bit now. So I'll give you guys some time to think about this, and then we can come back and figure out what the answer is. All right, now let's come back together. So the correct answer to this question is B. Because ASCII time, if we go back to our code, um, where's ASCII time over here? ASCII time, ASCII time. Here it is. So going back to our code, ASCII time formats their dates, starting with the weekday, and then the month and the day. So the B is the only one that does the weekday, the month, and the day. So we know that this is the correct ASCII time one. And we can also put this code into our interpreter to see. So this is the quiz question. Running this, we get Sun, September 20th. Yeah, 2010, which is what we expect. Okay. Any questions about that quiz? Oh, I forgot to resume my share. Sorry, guys. Sorry, guys. So what I did was I ran the ASCII time code, and I got the answer, and we got the answer. So it starts with the weekday, and then the month, and then the day. Um, so yep, so that's how ASCII time formats their date time. Any questions about that quiz? All right. Next quiz. What will be the output of the following Python code? We have, so we're just changing our T pretty much. So I'll give you guys a minute to think about this question. Well, actually, we're doing a bit more than changing our T. Um, so I'll give you guys one hint. There are less arguments in this T than there were in the previous T. All right, so let's see. Let's come back together. The correct answer is D. This will output an error. Now, this should output an error because there are less values for T, and Python is expecting more stuff. So if we run this, yes, Audrey, you're correct. Good job, Audrey. Good job, Henry and Landon. Um, so if we were to run this, we'll get an error because, see, and Python will just tell us that ASCII time that we're given it an illegal time tuple argument, meaning that we're missing some stuff. Okay. Okay, another quiz. True or false? We have S is equal to time dot time, and then T is equal to time dot time. And then we want to see if S and T are equal to each other. So the question is, are S and T equal to each other? So true if they are equal, false if they're not equal to each other. Yep. So the correct answer is B. S and T are not equal to each other because the number of ticks between S and T are going to be different. And we can confirm this too by running the code. Oh, oh, they're actually what? Oh, that's weird. I guess they're true. I guess they are equal to each other. Wait, hold on. Let me print S and T. Huh. I guess they are equal to each other. You know what? I think I can figure out how to make them not equal though. Okay. Yeah. All right. So what? Okay. So here's what the deal is. So it turns out that S and T are equal to each other if we run the code this way. If we set S equal to time dot time, and then we set T equal to time dot time right after that. So if we do that, then S and T will be equal to each other. But if we do time dot sleep one, so we make the program sleep for 1 second in between creating S and T, we can make it so that these two values aren't equal to each other. So now we're getting false. But the answer to the quiz is actually true. And it's true because we're creating S and T at the same time, pretty much. So since they were created so close to each other, they're gonna have the same ticks. Any questions about that quiz? Yes, Audrey?
Wait, so basically in order to make them it like false, you have to make them at different times.
Yep, yep. That's exactly it. So what I did to make them false was that I made the program sleep for 1 second in between creating S and T, and that's how I made them false. But without that, um, S and T will be created at the same time. Um, and yeah. All right. Any questions about date time in Python before we move on to the calendar? All right. Oh, and I just want to remind you guys about the homework from last week. So it's due today. It's due today. So if you did it, make sure to hand it in. And if you have any questions about last week's homework on exception handling, make sure to let me know or to post it in the Google Classroom. All right, moving on. So calendar. The calendar module gives a wide range of methods to play with yearly and monthly calendars. The functions and classes defined in this module use an idealized calendar, the current Gregorian calendar extended indefinitely in both directions. Year 0 is 1 BC, year negative one is 2 BC, and so on. So we can think of the calendar module as a more powerful version of the time module. So here we print a calendar for a given month. Well, we need to import calendar. Right, so what is this code doing? This code, we are setting the cal variable to be equal to calendar.month and then 2018 1. So we're giving it a year and a month. And then we're printing the calendar. So let's see what this does. Ooh, look at that. This is a really nice output, huh? Yeah, so the calendar module gives us a really nice output. So what this does is that it gives us the calendar for January 18th. And we see it here. So let's do the calendar for June 2023. So this is the calendar for the current month. Right now we are right here. Okay. So let's take a look at some of the uh, methods in the calendar library. So the calendar module allows you to output calendars like the Unix cal program. Let's see what else. We have iter weekdays, iter month dates. So all these methods that start in iter, ITER, pretty much allows you to iterate through weekdays or months or month dates or month days or what have you. We can get, so text calendar is another one, format month, format year, HTML calendar. That's another way to print out a pretty calendar, format year. So the calendar library can do a lot in Python. So let's try out this code and see what we get. So here we're printing the calendar of year 2018. So now we're printing the full calendar, given the year and some other arguments. So this is the full calendar of 2018 right here. On all of it is pretty printed. From January to December. So it looks like my birthday is going to be on a Friday. That's neat. October 5th. And looks like Henry's, wait, no, was it Henry's dad? Henry, what was it, your dad's whose birthday, September 20th?
Yeah, September 20th.
So yeah, so we can use the calendar module to print out calendar in a pretty way. Do you have a question, Audrey?
No.
Okay. So we can also use the calendar module to get the month name. And we can do that by iterating through calendar.month name. So what we're doing in this loop is that for name in calendar.month name, we're printing name. So if we run this, we get all the month names from January to December. So yeah, that's it. Okay, guys, I'll be back in just 1 second. I need to get my cat off the counter. Sorry about that. My cat was being naughty. Okay, so we just printed out all the month names. Let's see what else we can do. So exercise. Write code to print out all weekday names one by one. All right, how can we do that? We want to write code to print out all the weekday names one by one. And that would involve, the code for that's going to look a lot like the code for this, for printing out the month names. Uh, so we may have to go back to the documentation to figure this question out because uh, we don't really know how to get the weekday names. But let's see if I can find something quickly. Okay, okay. So to print out the weekday names, we replace month name with day name. So by replacing month name with day name, we get all the weekday names from Monday to Sunday, as we see over here. All right, any questions about that? About using about iterating through month names and day names? All right. Let us move on. So we can also use the calendar module to create an HTML formatted calendar. So we can save the output to an HTML file and see the results. So let's run this code and see what we get. So our HTML calendar, we can create that with calendar.html calendar and then calendar.thursday. And then we do some formatting. So let's run this and see what we get. Oh, geez. Okay. So, so just a quick question. How many of you guys are familiar with HTML or have at least heard of it? Right. So HTML is essentially um, the language for the language of the internet. Um, yeah, for like building websites and stuff. So what we see down over here is an example of HTML. So if we were to copy this into an HTML file and like so if we were to copy this into an HTML file and then open up the file in Google Chrome or something, then we'll get an HTML calendar. But it looks kind of weird right here because it's in the Python console. Um, so you guys can use this for reference if you want. So yeah, I guess we'll see. Actually, I will save this to an HTML file so that we can really see what this means. Um, yeah, let me open this up in Chrome. I'll just use Firefox. Oh my gosh. Yeah, I'm trying to get this HTML file up and running, but it's being uncooperative. So I'll just skip this step and come back to it later on, maybe. Yes, Audrey?
Can you send it in chat?
Yeah, I'll do that. Good idea. So it might be easy for me just to post it on the Google Classroom because if I post it in chat right now, I mean I'll post it in the chat. We'll see how it comes out. Hopefully it doesn't. I hope it doesn't come out too ugly so that you guys can still copy it. Oof. Okay. Yeah, I'll post this on the Google Classroom as well. Good idea, Audrey. So I suppose this would be a good place to stop for today. It's about 7:30 now. So starting with the next lecture, we'll start with date time, which is another way to which is another way that Python handles dates and times. Um, so we will finish off this lecture next Monday, and then I'll send the homework next Monday. So you guys will have another week to do the try exception homework. Yes, Audrey?
I got the HTML thing to work on my computer. Can I share my screen?
Oh yeah. Go ahead.
Uh, yeah.
Is it on another screen maybe? Because we see
Um,
your code.
can you just give me a second?
Yeah. Ooh, very cool. Very cool. All right. Yeah. That's really cool. All right, very good job, Audrey. You're a natural at this. All right, so as Audrey has just shown us, that was an example of an HTML formatted calendar that we created with Python. So yes, claps for Audrey for getting that to work for us. And yeah, I'll see you guys next week.